Day 3, we are going to practice with arithmetic and geometric sequences. In class, we're going to have a bunch of stations set up, and you're going to go around and identify arithmetic, geometric, and practice writing the recursive formula. But before we do that, let's do a quick warm-up. For each sequence, determine if it's arithmetic or geometric. Once you have done that, write the recursive rule, identify the common difference, D, or the common ratio, R. Okay, so take a look at the first one. Again, if you have no idea, take one term and just subtract and see if you subtract every time, are you getting the same number? And if that doesn't work, then divide. So take any number, divide by the one before it. But yesterday we talked about if it alternates from positive to negative, then it's probably geometric. So let's take any number and divide by the one before it. So I'll show you what I mean by that. I'm going to pop out my calculator. And you can do this with any number except for the first term because there's no number to divide it by. All right, so I'm going to pop up my calculator, and I will pick one number, divide by the one before. I'll try it a few times, and if I get the same thing, that is our common ratio. So this takes a second to load. Okay, let me open a calculator here. Okay, pick any number, divide by the one before, so I'll just do negative 2.125. Divide by the number before it, 4.25. Okay, so this would be our common ratio if it's geometric, negative 0.5. Let's try it again. So I'll take that 4.25, divide by the number before it, negative 8.5. We get the same thing. So that should happen every time. And what that means is we're multiplying by negative 0.5 to get to the next term. So this is geometric because it has a common ratio. We're multiplying by negative 0.5 every time to get the next term. So this is geometric. Oops. The recursive formula, again, we always need a starting value, otherwise we could get a different list of numbers. And then to find any term, you take the term before it, and we multiply by negative 0.5. So that's geometric. Our common ratio is what we're multiplying by every time, so here it's negative 0.5. All right, let's try the next one. Again, you could start dividing 28 divided by 25, 25 divided by 22, if we get the same thing as geometric, but here it is arithmetic. And I know that because if I subtract 28 minus 25, I get 3. 25 minus 22, I get 3. So this is arithmetic. The recursive formula, we start with our first term always. To find any term, you take the term before it, and we're going to add 3. So this is a common difference, and the common difference is 3. Okay, so 2 more problems, and then we're going to do our little activity in class. In lists of numbers, we often start by calling the first term a sub 1. However, there are certain instances where it is more appropriate for the first term to be called a sub 0. So again, in lists of numbers, we say this is the first term, second term, third term, fourth term. But sometimes there's like a 0 term. So here are 2 examples of something where the first term would be the 0 term, so a sub 0 instead of a sub 1. So Abraham puts $100 in the bank. Each month he adds 50 more to the same amount. So arithmetic or geometric, here's our clue. He's adding 50 more, so this is arithmetic. The common difference would be 50. All right, for here though, the recursive formula, I would say his starting value. So he goes to the bank, his starting value is $100. So a sub 0, the starting time is 0. And then a sub 1 would be like, what is his amount after 1 month? So let me write the formula first. So a sub n equals the month before it, and we're adding 50. And so why it's more appropriate to start with a sub 0 here is because a sub 1 would be after 1 month. After 1 month, he takes his $100 and he adds 50 to it. So after 1 month, he has $150 after 1 month. So in this case, if you're depositing money, it makes more sense to say a sub 0, the original amount, and then a sub 1 would stand for after a certain amount of time. After 1 month, it's $150 in his account. Here's one more example. A zombie enters SLP High School. After 1 hour, there are 3 zombies in the school. And after 2 hours, there are 9 zombies in the school after 3:27. Here's a table if I make a table of this. So X is time, Y is amount of zombies, time, zombies. All right, so here's appropriate to say that zombie enters the school at time 0. After 1 hour, there's 3 zombies. After 2, there are 9. And after 3, there are 27. So this one, is it arithmetic or geometric? You can see it's multiplying by 3 every time. So this is geometric. Our common ratio is 3. Again, here the recursive formula, it makes more sense to start with the initial value. So the initial value, a sub 0, 1 zombie. Here's the recursive formula, a sub n equals a sub n minus 1 times 3. And then when I ask you for a sub 1, it means after 1 hour. So here it makes more sense. After 1 hour, there are 3 zombies in the school. So again, here's a case where a sub 0 is a little bit more appropriate than a sub 1. Again, lists of numbers, it does make more sense to say, all right, here's the first term, second term, and so on. But when you're looking at like investment problems or zombie problems, it makes more sense to start at time 0. So in class, we'll do an activity practicing these ideas and as kind of a review.